let's continue to solve Leetcode problem flip game 2, 294. Yeah, so it's the same like before, but this time the current state is gonna be the plus and minus sign. Yeah, and it can be any length. So the length can be 1 to 60, and the current state I should be plus or minus sign. Yeah, and we also need to calculate the runtime complexity. Yeah, because this kind of algorithm actually it is used similar like backtracking. So the runtime complexity we need to analyze a little bit. And let me first explain this problem in the whiteboard. After that, I'll go to the code editor to finish the coding. And for this problem, I'm gonna use bit mask to solve the problem because this number is just 60. And for each time, we can do two operations. It means for a continuous plus sign, we can turn it to the negative sign. Yeah, this is just for each of the operation. But for Alice and Bob, there are still two people can play optimally. So finally, we're gonna just return a true or false. It always depended, yeah, on the question. Let's go back to the question. Yeah, so the condition is return true if the starting player, if the Alice is starting player, Alice can guarantee a win. Yeah, so the game ends when person can no longer make a move. So for example, for this one, yeah, if Alice take the 2 plus sign in the middle and Bob cannot take the operation, so this means Alice will win. Yeah, because Bob cannot do the operation. So yeah, it's like the game theory in the real games. Yeah. Now let me analyze how to solve the problem. For me, first of all, I'm thinking about this problem as a DFS problem. Basically, it is backtracking. But this problem, as we are giving a 60, and for each operation, we can do, yeah, a continuous plus sign and make them to negative sign. So this means 2 to the power of 30 is enough for the calculation. So I'm gonna use the bit mask for the DFS. So basically, yeah, for random sign, it can be plus, it can be plus minus, but it will be some sign like this. Yeah. And for me, I will make a record as my state. So the state will be the bit mask, the binary calculation of this number. Yeah, so for this number, if it is a minus sign, I'm gonna call it a bit 1. If it is a plus sign, I call it as yeah, if yeah, I think it's gonna be the same. But for the calculation, for the current initial state, I'm gonna use the negative sign as bit 1, and the plus sign as 0. So this is 0, 0. This is 1, 1, and 0. So this is my current state. And what I'm gonna do, I'm gonna use the DFS, go from the current state to check for the next. Yeah, so if we are having a string like this, so for each time I'm gonna check if there are two continuous plus sign. But how can I check? Yeah. So basically I need to use the bit mask to check if this is a plus sign and if this is also a plus sign. Yeah, if they are both plus sign, what I gonna do? So I can turn it to the minus sign and go to the next DFS. Yeah, but if this is visited, if this plus sign and this plus sign has already visited, so I can just use a continue, go to the next DFS. And if Alice and Bob, if this Bob lose, so definitely Alice will win the game. Yeah, I think it's difficult to explain, but just let me go to the code editor to explain the code. Yeah. So I'm gonna prepare a DFS. Inside of the DFS, I'm gonna prepare a state. Currently, I will give a pass. Now I need to prepare the state value. So what is my current state? Yeah, because this current state cannot be 0 because they are not always plus sign. It can be negative sign. So I need to prepare the current state. So for I in range len of the current state, I need to check if this current state I equal to minus sign. This means I need to use the bit manipulation to get my result. So my result should plus equal to this I should be shifted 1 should be shifted to the left side, and how many positions it should be shifted to I positions. So this means yeah, if the first character is a minus sign, it's gonna be 0 plus 1 because this I is 0, so it's gonna be a 1. Yeah, so finally I'm gonna calculate what is the result. Basically, I'm gonna count how many minus sign, and this is for me. This is the low bit, and to the right side, this is the highest bit. So this is why I'm gonna calculate my current state. Yeah, now I can put the state inside and get the result. I just needed to put the result inside and return this DFS. So this is for preparations. Basically, if they are always positive sign or plus sign, yeah, my current state is just 0. If there is a negative sign like this, yeah, so basically I need to prepare. So this is a 2 and this is a 4. 2 plus 4 is a 6. So basically I need to put 6 inside. Yeah, so this is my current state. Now I need to write the DFS. So for the DFS, basically I need to check this function if I can find two continuous plus sign. Yeah. So for I in range len of the current state minus 1. Yeah, because I just need to go to the second last. Yeah, because basically for each operation I need to check two continuous sign. Yeah, so this is why it is length of current state minus 1. Now I need to check a continuous station. If it is inside, basically I need to continue. Yeah. So if this state, let me. Yeah, if the state shifted to the left side to I positions and 1. Yeah, so if this state shifted to I bit, yeah, it means basically in the I bit, if there is a 1, if this bit is a 1, it means it is a plus sign. Yeah, so basically it means it is a negative sign because I'm gonna use 1 to represent the negative sign. So if I find a negative sign, but I need to check two continuous negative sign. Yeah, so I need to check the next bit. So it is, let me copy this one. Yeah, so basically this is the state shifted to, here is I, but this time it's gonna be I plus 1. Yeah, because I need to check two bit. If this two continuous bit will be always be a minus sign, so I just need to continue. This is also 1. Yeah, so if it is at 1, and yeah, basically I just check the two continuous sign if they are both minus sign. So I'll let it continue. So I will jump to this step and go to the next step. So for the next step, if Alice and Bob, if this Bob loses the game, so if, yeah, so this is basically the template for the same game theory. So yeah, so my current state is Alice. I want to check if Alice can win the game. So if Bob loses the game, it means Alice must win the game. Yeah. So I'm gonna return a true. Finally, if Alice cannot win the game, so the Bob must win the game. So Bob will return a false. Yeah. So let's put the Bob state. So it means yeah, if it is a minus sign, it will continue. If it is not, it means for this character, it must be a plus sign, and a continuous one, it's gonna be a plus sign. It means I find two continuous plus sign. Yeah. So what I needed to do, I needed to check the Bob state. So Alice and Bob, I will check the Bob's state. I needed to update the Bob state. Basically, it is or with this I with this 1. Yeah, because I needed to put it inside. I needed to put this bit inside my state. So I needed to use a or. So this 1 should be shifted to the left to i's positions. Yeah, so this is just one operation, and now I need to check the next one. So the next one is, let me copy. Yeah, so the next one gonna be the 1 shifted to gonna be the same I plus 1. Yeah, I also noticed I made a mistake here, this end. Yeah, so this is basically, this should be, yeah, should be all. Yeah, this is all. This is means I need to put 2. If I find, yeah, if I find 2 minus sign. Yeah, this means if I find 2 minus sign, yeah, or I find 1 plus sign and 1 minus sign, I still let it continue, because for 1 plus 1 minus, we cannot do the operation. Or if I find a minus and plus, I will still let it continue. So this is for the continue. Actually, there are 3 combinations. So this is why I need an or here. Yeah, basically this is the entire code. Now let me run it to check if it works. Yeah, as you can see, it works. Now let me submit it to check if it can pass all the testing cases. Yeah, as you can see, it passed all the testing cases. Now, as this is a bit mask and this DFS will just return a true or false for the state, we can add a case to speed up a little bit. Let me just add a case and submit again to check if it works. Yeah, as you can see, it is much faster than before. This is why, because we used the bit mask and we also used the case. So the time complexity now becomes 2 to the power of 30. Yeah, we are giving 60, but 60 divided by 2, it is 2 to the power of 30. But also inside, it always depended on the result and this state. Yeah, this is like the trimming, and this state is also like the trimming. So it may be less than 2 to the power of 30. Yeah, if I, yeah, I think basically that's all for the question. See you next